The Internet Gateway Routing Protocol, also known as igrp, is a proprietary protocol created by Cisco to improve the functionality of basic distance vector routing protocols. In this nugget, we're going to cover the basic setup and the commands associated to start up igrp on a router. We're also going to look at the commands we use for monitoring to show the operational objectives being met by igrp. Then we will illustrate how the passive interface command can be used to save valuable bandwidth and at the same time allow an interface to participate in an igrp environment. Following that, we're going to demonstrate two redistribution commands and how they are used in an igrp router. Just like with RIP and igrp, there are two commands needed for the basic setup on a router to run igrp. The first one is router igrp, and it's going to be followed by an AS number. Now this is kind of a lie, or it's at least misleading. It says AS number because Cisco recommends if you have an autonomous system number assigned to your organization, enter it here. If you don't have one though, this can be any other decimal number. And it's really more like a process ID, and it identifies igrp routers that want to talk to each other and participate in the same routing environment. Not only does it allow us to have two routers, let's say router 1 and router 2 here, speaking in the same and trading information in the same igrp routing environment, it also allows us something that RIP wouldn't allow us. On one router, let's say in R2 here, we can have two instances of igrp running. One with an autonomous system number that is shared with R1, and in another instance with an autonomous system number shared with R3, and they're both different. And what that's going to cause is a separation in our network logically, where we're going to trade routes here, and then we're going to trade routes on this side. In some cases, you might find an advantage for that within your networks. And the good thing is you can also share routes from one autonomous system running igrp with the other. We're going to cover that later in this nugget. The second command that we're going to need is the network command. This network command does not differ from the network command we use when we set up RIP. It's going to have a network number here, not a subnet number, and that's to say that it is classful. And the fact that if we put a network number that starts with the first octet being in a Class A range, 8-bit mask automatically. Class B range is 16, Class C is 24. Now because that's true, and we might have on our routers interfaces subnetted, so we might have a 10 network, let's say 10.1.1.0 here on this side, 10.2.2.0 on this side. If we put in here network 10.anything, it's going to recognize that the 10 makes it a Class A address. It's only going to pay attention to the first 8 bits, so the network that it's going to pass along is 10.0.0.0, which means it's going to activate both of those interfaces because they're both part of the 10 network. All right, let's activate igrp on our first router, which is going to be router 1 in our diagram. First of all, we need to gain access. Use the enabled command to get to the correct mode, and then we're going to configure via terminal. All right, first command is router, igrp, and now the autonomous system number. I'm going to use 5. Okay, then we're going to set up the networks. If you recall from our diagram, there's two networks on each side, one network on each side of router 1. On one side, 192.168.1.0. You see that here. On the other side, 192.168.2.0. So those are the two networks that we have available to activate this command. I'm only going to activate this network here for now. 192.168.2.0. All right, let's close that out. Now we have igrp running on one network on router 1. Let's go ahead and shut this part down. Bring up router number 2 and configure it there. All right, gaining access first. Get to the configuration mode. All right, first command, router, igrp, and we're going to stick with 5 at this point. igrp 5. The network that we're going to identify is going to be this same network. I want to share the autonomous system of 5 right here. All right, so network 192.168.2.0, and we've got this router configured for router igrp5 on this side. What I also want to do is I want to make another instance of igrp running on this one router, and it's going to have an autonomous system number of 10, and it's going to share its routing updates with router number 3. So let's make those changes here. Get to the correct mode. All right, we can use the up arrows. Router instance now is going to be 10, and the network that we want to use is going to be 3.0. Love those shortcuts. All right, so we have that configured. Now what we have to do is go over to router 3 and make the same configuration. But first, let's go ahead and save out of here. Copy run to start to save our work. And there we go. So the next router in line for setup is router 3, and we're going to get to its configuration right here. Let's gain access, enable command, and then we're going to config from terminal. All right, the command is router igrp. Remember, this instance is going to be 10, shared between R3 and R2. All right, and the network command, 192.168.3.0, which is this network right here. All right, Control Z to get out of here. Let's copy our work. And then what we're going to find is that we should be able to trade routes now between a couple of routers, R2 to R3 and R2 to R1. The thing about that is we haven't set up this interface to be advertised via routing protocols for R1. So R1 really has nothing to tell R2 that it doesn't already know. They share this network. The same for R2. The route that it knows of here, it can't share with R1 because in that instance of igrp, instance number 5, this interface is not advertised because it's not identified with a network command. Same thing happens on the other side. Lucky for us, just like in our RIP protocol, we don't have to trust that this is working. We actually have commands that are given to us so that we can verify the operation of igrp on our routers and across our networks. The first command, just like with RIP, is the show IP route command. Except in this case, instead of looking for the R that identifies routes that are learned via RIP, we're going to look for the I, the capital I, which stands for igrp now. And then we're going to have the show IP protocol command. It's going to give specifics to the igrp instance that we're running. And we're going to look at that in depth as we get into the routers. Now here's where it gets a little different. We have two debug commands available to us. If you remember in RIP, it's debug IP RIP. That's the only one we have. Here we have debug IP igrp transactions. This is going to give us a very similar output as debug IP RIP. It's going to show us in detail the routing updates as they're transmitted or received from whatever router we're on. Then we have debug IP igrp events. Okay, this is less detailed as far as what's in the routing update, but it does give you different types of information. Probably the most prominent is the fact that it's going to identify the routes that are transmitted as either interior, system, or exterior routes. Let me draw a simple diagram to illustrate exactly what we're talking about there with the different types of routes. All right, I have 3 routers, connections between them, between all 3. I also have, hanging off this router, an interface that has 2 different subnets off of it, A and B, and this is going to be done with sub-interfaces. We also have autonomous systems that are separated here for our igrp routing protocols. I say this is autonomous system number 5, and in here we have autonomous system number 10. All right, routes that are passed here between the 2 autonomous system numbers are known as exterior routes. Routes that are passed to this interface here are known as interior routes. All right, and then system routes are routes that we would learn from the other side of a router. Let's say that this router also had an interface here with subnet C. This update here would be a system route update to igrp. All right, just so you know the background as to what we're going to be looking at when we bring up this command. The first command we're going to use is the show IP route command. But remember, we're not distributing any routes via igrp yet because of the bare bones configuration we've done so far. In other words, if we get on router number 2 in our diagram, we will see that we are sending out updates via both interfaces from router 2, but we're not receiving anything because there's nothing to pass. In fact, it's those null suppressed updates. So what we'll want to do first is get on router number 3 here, and we're going to add another network to our igrp routing protocol. All right, it's number 10. All right, let's add network 192.168.4.0, which is, .0 instead of .40, which is the interface on the far side of our router. Let me get you back to that diagram. It's this interface here. And so now by activating that within igrp 10, we're going to be able to pass this network over to R2 via updates here. All right, let's go back and do that. Let's Control Z to get out of this and save our work. All right, now what we want to do while that's saving is run over here and jump on router number 2. Let me lift this up so that we can see it better. And what we're going to do is do a show IP route. All right, nothing as of yet has come in. What do we do from there? We use our second command, which was show IP protocol. Remember, this is going to give us specifics about what's going on in our routing protocol. Let me make this window a little larger because just as it was in RIP, there's a lot of information here. First of all, it's going to tell us the routing protocol is igrp. We're going to send updates every 90 seconds. This is programmable, but just like in RIP, they should be the same on every router, so I'd advise that you just leave it alone. The next update is due in 6 seconds. This is the update that we transmit out of this router. And then it's got general timers here. All right, what you're going to see down here is the networks that are participating in this instance of igrp. And we're also going to see routing information sources. We don't have any as of yet because they haven't talked to each other. All right, now, here's igrp instance number 10. We have 2 instances, same thing, updates every 90 seconds, next due in 42 seconds. And let's get the rest of our information. All right, the network that's being used here is 192.168.3.0. No routing information source as of yet. Remember that these update timers are telling us how often we're going to send out the information. It's not telling us when we're going to receive. And what's going to tell us that is if we do a debug. So let's start with that. Debug, IP, igrp, and now this is where we have the choice between transaction or event. Transaction is what we're going to be familiar with from our nugget on RIP, so let's start with it. Transaction. All right, it's on, and we're going to see information floating back and forth as it's coming from the other router. But right now, let's go ahead and take a look at our IP route table. Show IP route, and there we go. We have our first instance of igrp, and you can see that here up in the legend, reporting a network to us, and it's 192.168.4.0. Now, we also see here that in between all these things that we were doing, that igrp sent an update again to the broadcast, just like RIP does, out of serial 00 over to 192.168.2.2. This is our igrp instance number 5. Soon, we should be seeing the instance number 10 sending an update as well. Not actually sending it, I mean, it's saying sending an update here, but again, remember, it's suppressing a null update. All right, so that should come up momentarily. And if it doesn't come up real soon, we'll go ahead and move on anyway. That is our debug IP igrp transactions. Let's change that. And at the same time, let's look at events so I can show you the difference. All right, there is the received update from 3.2 telling us about network 192.168.4.0. I'm going to turn on events now. All right. What we're going to get different on events, as I told you, is not the detailed information of what's in the update, as we see here, but simply that an update occurred, and it's going to tell you the types of updates that were in there, like here. 0 interior updates, 0 system updates, and 0 exterior routes. Now these are the routes that we explained in our little diagram earlier. Let me turn the debugging off so it doesn't get too confusing on the screen. And there's no debug all. And we can also see the instance of igrp sending an update out 000 to 192.168.2.2 as we saw before. And then we see up here where it sends it out 002 to 3.1. So we have both igrp instances 5 and 10 sending information out. At this point, we could go over to router 1, set up the network for 192.168.1.0. That way, it would advertise via igrp instance number 5 here, this network over to router 2, and we would have a convergence on our network. But what we're after this time is more of an optimal configuration in that convergence. Not just the end goal, but how we get there. So it's going to be important that we use some smart commands. One of the first we're going to use, or have the option of using, is called the passive interface command. Let me explain down here on the diagram what that's going to do for us. When we added this interface here as a network to our igrp routing protocol, it now said, I am going to do 3 things. I'm going to advertise routing updates out of this interface going in that direction. I'm also going to listen for routing updates coming back in. And I'm going to take this network or subnet number, whichever it may be, convert it, if it's a subnet number, into a network number and advertise it over every other network that is participating within igrp. Now you see the waste here. If I transmit updates out of this interface and all I have is host out here, nobody's listening and I'm using valuable bandwidth to do that. So that's where the passive interface command comes in. What it's going to do is it does not transmit right here. So it doesn't do that, but it does the other two steps that you would normally get out of adding the network command to an interface. It is going to advertise this network space out all other interfaces that are igrp enabled. So here, it's going to send it out. And at the same time, it's going to listen for routing updates coming in. So if there were any host here that had RIP enabled, it could actually talk to this router, and then that router could make the other router, R2, aware of the changes that are being made. This is when we would use a passive interface command. But remember that I said we're out looking for an optimal use of this network for our convergence. So for that, we're going to take another step. We're actually going to look at the redistribute commands. The first one that we're going to look at is redistribute connected. What is this telling us? It's saying that if I have an interface here, E0, that I don't want to activate within my igrp instance, and this interface is, I simply redistribute connected within that instance of igrp, and any other interface out here that's connected, we're going to take that network number and we're going to advertise it in this direction. So it does this one better, where before we wouldn't advertise, but we were going to listen to it coming in, so we cut out the advertisement. This time we're not even going to listen to it coming in. We're simply going to take this network number and advertise it out of this space so that we can have convergence without any overhead here or the waste of CPU time for this router to listen for updates on that network. So let's take that back to our network diagram and the passive interface example. Again, if we had a host here that might be playing in RIP and advertising, then we would use passive interface. But because we know N2 is not, we're going to use the redistribute connect. Before we leave though, let's go over the syntax of this command. Passive interface, then the hardware type. Now this is going to be Ethernet, serial, loopback, null. So it's that type of hardware that we're looking for, and then the interface number. So an example could be passive interface E0. All right, and you can use that at your will in your network whenever you need to. But for this example, we're going to use redistribute connected. Let's go into our routers and start that up. First of all, let's go into router number 3. I've gained access already. We're going to go into the configuration mode and make these changes. As we get into this configuration mode, we have to remember that within router igrp instance 10, we did set up a network command for 192.168.4.0, right? And we set that up so that we could send this network information from R3 to R2, and using our monitored commands, we could see that as a learned route via igrp. Because we set that up, we're going to have to go and take it out. And what we do is just take the command, put a no in front of it, and hit enter. Now it's gone. Now we're going to set up our redistribute connected. And I'm going to spell right. Redistribute connected. This is going to take every interface, in this case there's only one, but every interface on this router, and allow it to send updates that include that network ID. So now that we've done that, let's go over to router number 1 and do the same exact thing. As you can see here, I've gained access just like I did before. We're going to go into the configuration mode, get into the router igrp instance number 5, and then set up redistribute. And it's for the connected interfaces. That's 2 ends. All right, once that's done, let's close it up. Let's save our work. And now what we're going to have is a near instance of convergence. We're not quite there yet, and let's see why. We have an autonomous system number 5 on this side running igrp. So now with the connected command being redistributed, this network is learned by R2 because R1 sends it to them. And 192.168.4 network is learned by R2 because R3 has that same redistribute connected statement in there, sending it to R2. Our problem? R3 has no idea of this network here, and R1 doesn't know of the far end network here. What do we have to do to make that happen? We have to take both of these down, redistribute igrp and autonomous system number after that. So what we're going to do in essence is we're going to take instance number 10 of igrp and say redistribute everything you learn on the 5 side into 10. And then we're going to mirror that. We're going to say everything you learn on the 10 instance of igrp, send that over to the network, to the routers that are on network igrp that uses autonomous system number 5. So then we're going to have true convergence across our network with this command. Let's get into that, and we have to actually put that into router 2. You'll notice every time that I switch windows here, I let you know which router we're in, and I show you the access that I gained into that window. The reason for that is I'm trying to give you a reference point every time that we enter commands. And what I could do is I could go ahead and telnet once I gain access into router 1, into router 2 or router 3, but I just felt that would be too confusing. So I use the secure CRT and these serial connections going out of my COM ports, and I'm limited to 2, but I'm configuring 3 routers. And that's why you see some reuse of COM2 bouncing from R2 to R3. But every time we do bounce from one router to another, I do give you this bit of information here and show you a reference point of where we're at. So right now we're on router 2. We're going into config T, and we're going to try our redistribute igrp commands. But remember, you have to be in the correct mode of operation within config to do that. So the first igrp instance we're going to get into is 5. And what we do is we type in redistribute igrp and the instance that we want to send updates of those routes into our igrp instance 5, which is 10. All right, and then we just mirror that. Let me exit out of here, get back to the right level. We're going to change this to 10, and then I'm going to redistribute igrp 5 into it. All right, let's close this down. And now we're going to be able to look at our route tables, look at our other monitoring type commands, and see the effects that this change had on our routers and our network. The true test of convergence here is going to be getting on router 1, and then after that getting on router 3, looking at the route table and ensuring that we have knowledge of the distant end networks. So let's start with router 1. All right, again, I logged in. My show IP route command is ready to go. Let's hit that. Excellent. There we go. All right. I have knowledge of the network 192.168.4.0 from igrp. So that's that network here. And I also know about 3.0 from igrp as well. So both of these routes were sent in via the instance of igrp 10 being redistributed into my instance of 5. Pretty cool, huh? All right, on to the last test to see if we've achieved convergence with an optimal network configuration. And that's looking at R3 and doing the same show IP route. Now we're going to switch again. I'm going back to COM2. Look, we're at a different router. It's R3. I've logged in. So the reference point is I'm at the privilege mode, and I'm about to issue the command show IP route. All right, with that done, here we go. 192.168.1.0, this network, and 2.0, this network, were learned by router R3 with the redistribute command. I love these commands. Now, if you think back all the way back to the nugget where we talked about manual configuration within a network, do you see how much easier this is? And it's getting easier. As we get out of distance vector protocols and look into link state protocols, they actually do more work for you, and there's more flexibility in the work that they do. In this nugget, we learned that the router igrp and the network commands are used to get us to a point that we have a basic setup of igrp on a router. Then we looked at 4 different monitoring commands that we can use to verify the operation of igrp on a router. They were show IP route, show IP protocol, debug IP igrp transactions, and debug IP igrp events. We followed this with a look at the passive interface command and how it can save bandwidth on our network while at the same time allowing an interface to participate at least halfway in an igrp network. Because we were shooting for network efficiency, we chose instead of the passive interface command to run the redistribute connect command on our networks so that we could save complete bandwidth on individual subnets that didn't have any other routers or hosts that wanted to participate in igrp. And we ended up by redistributing one instance of igrp into another so that we could achieve network convergence. I hope this has been informative for you, and I'd like to thank you for viewing.